All right, here are our solutions for perfect problem 5 for Math 251. This problem is actually pretty tricky. You're asked to derive the fact that the derivative of arcsine is this mess right here. And the trick to it, well, I kind of give you it in the hint. I say start out with y equals arcsine of x, and then use implicit differentiation. The idea with implicit differentiation is I'm eventually going to take the derivative of both sides of this equation. But I don't want to do that until I know what the derivative of each side of the equation is. If I did it right now, I'd have to know the derivative of arcsine, and I don't know that. So what I'm going to do first is I'm going to do some algebra, or I guess some trig. I'm going to take the sine of both sides of the equation. That'll get me here. And now I can take the derivative of both sides. Of my equation here. Well, the derivative of sine of y, remember you have to treat the y's differently. The y is a function, whereas the x is just a variable. This would be a chain rule problem. My outside function is the sine of this thing, and then my inside function is this thing y here. So when I take the derivative of sine is cosine. I'm going to leave the inside function alone, but then I'm not done. I have to multiply that by the derivative of y. So I get cosine of y times y prime. On the right-hand side, the derivative of x is just a 1. So what I get is that y prime is 1 over the cosine of y, which, since I wrote up here that y is the arcsine of x, I could say it's 1 over the cosine of the arcsine of x. That is my derivative. That's fantastic. That's the right answer. Y prime equals 1 over cosine of arcsine of x. But that's not what it says right here. So why is this different than what it says right here? Well, I'm going to have to do some simplification. So I'm going to simplify the cosine of the arcsine of x. I'm going to do this simplification over here so that I can rewrite this thing. Note that I'm just simplifying the denominator, so that's what will go down on the bottom here. So the trick that I have for doing these is I let t equal, not like this is my trick, but this is the one that I taught people that took my Math 1 and 12 class, is I do this substitution. The inverse trig function that's nested inside here, give that a name, maybe call it t. So then really this thing simplifies to just the cosine of t. And what I'm going to do is figure out the cosine of t by drawing a right triangle. I'm going to label my angle t. I can kind of arbitrarily put it down here, and there's my right triangle. I'm going to label this triangle. I'm going to use SOHCAHTOA, the fact that the cosine of t is equal to the ratio of the adjacent side and the hypotenuse of this triangle that has t in it. And the way I'm going to label this triangle is use this statement. If t is equal to the arcsine of x, then the sine of t is equal to x, which I could write as x over 1. And so if the sine of t equals x, that means the ratio of the length opposite this angle to the hypotenuse, that's the SOH in SOHCAHTOA, is x to 1. So I can label my triangle like this, and I could figure out this side length down here. Well, to figure out this side length, I could use Pythagorean theorem. What I'd find out is that this is equal to the square root of 1 minus x squared. Maybe I should show you that somewhere. Let's call this a. I could do that off to the side. I could say a squared plus x squared has to be equal to 1 squared. It's Pythagorean theorem. So I want to solve for capital A. So I can subtract x squared from both sides of the equation. Note that 1 squared is just 1. And then I can take the square root of both sides of the equation. Technically, I should put in a plus or minus, but since I'm talking about side lengths, I don't need my plus or minus. It's a positive side length. So that's how I got this a right here. And so now that I have my sides labeled, I could figure out what the cosine of t was, because what I was trying to do was simplify the cosine of the arcsine of x, which I said was the cosine of t, and I could figure out the cosine of t by staring at this thing. It's adjacent, SOHCAHTOA, over hypotenuse. In other words, it's just the square root of 1 minus x squared. So then what I can do is I can take this answer. I just figured out that the cosine of the arcsine of x is equal to this guy. So instead of writing cosine of arcsine of x down here in the denominator, I can just write this guy, the square root of 1 minus x squared, which was exactly what I was supposed to come up with. I'll throw the check mark down there, and I'll say that I solved that part. And now that you have this, do some stuff with it. Do some chain rule. So this first one is asking you to figure out the derivative. So maybe this is this guy of, let's see, I got arcsine of something. What am I taking the arcsine of? 1 divided by the square root of 1 minus x squared. I'm going to write that as 1 minus x squared raised up to the negative 1/2 power. Because I think it'll benefit me calculus-wise to have things written like this. Negative because it's in the denominator, 1/2 because it's a square root. So now what I'm going to do is I'm going to take the derivative. I'm going to do the chain rule. My outermost function is the arcsine. I know that the derivative of arcsine of x is 1 over the square root of 1 minus x squared. So the derivative arcsine of all this stuff is going to be 1 divided by the square root of 1 minus all this stuff squared. And the stuff in this case is what's inside these parentheses, which is 1 minus x squared to the negative 1/2 power. But then I'm not done. I have to multiply that by the derivative of the stuff in the inside. What's the derivative of this part? Well, for that, I'd have to use a power rule. I'd bring this negative 1/2 down in front. I'd leave the 1 minus x squared part alone, and my new exponent would be negative 3/2. But then I'm still not done. I have to multiply that by the derivative of the inside here. I just took care of the exponent. I still have the 1 minus x squared part to do, and that derivative is negative 2x. So what I would get for my final answer is this thing here. If you didn't catch that, well, I'm about to do it again, except for a slightly different function. For this next one, I'm going to try to figure out the derivative of 1 minus arcsine squared x. So what I'm going to do is say, okay, I'm taking the square root of, maybe I didn't say that, a whole bunch of stuff. So it's raised up to the 1/2 power. And then what is this stuff? Well, it's 1 minus something that's getting squared. And that something happens to be the arcsine of x. So really what I have is something that's written like this, but if you write it in these terms, again, it'll make the calculus a little bit easier. My outermost function here is now this square root, this raised to the 1/2 power. So I use the power rule, I bring that down in front, and what I do with the inside is basically leave it all alone. Arcsine of x squared, which is the arcsine squared of x. I just think it's easier to write it in this form. But then I'm not done. I'm using the chain rule here. I took care of the outermost function, this 1/2. My next layer is take the derivative of 1 minus something squared. Well, the derivative of the 1 goes away. That's just 0. But for this minus something squared, what I'm going to have to do is use the power rule, bring that 2 down in front. So I get negative 2 times arcsine of x raised up to the 1 power, if you want. Then I'm still not done, because I still haven't taken the derivative of arcsine of x. The derivative of arcsine of x I have up here is 1 over the square root of 1 minus x squared. So you could spend some time to simplify both of these if you felt like it, but I'm going to go ahead and call those good because I think writing them in as a product of terms, or product of factors, I guess, helps show where all the different pieces come from and maybe lays out the calculus a little bit better. So I guess I'll stop this here.